Hi, I'm Andrew Armstrong and welcome to the Back of His Teardown Lab. Today we're going to be assembling this kit. It's a continuity probe by Mitch Electronics, and there's all the information there. Look, you can apparently scan it for instructions, but I guess I'm probably not going to do that. I'm just going to jump right in and see if we can figure this out. I do note, by the way, it does have resistors, and you know how I absolutely love reading resistor values. So let's see what we've got. We've got our circuit board, our 9-volt battery snap, our chip carrier, and we have a nice IC here. This is an 8AAL4JM, wherever that does. Bunch of passives, a buzzer, another chip on there, an LM358P, and some pogo pins. And actually we saw that on the packet. There is an LM358 and a 4093. I guess those are the main ones. So the interesting thing about this whole thing, and you think, well, why do you need one of these? Why don't you just have a battery and a buzzer? And that's going to give you continuity. Well, the problem is if you use that through sensitive circuitry, it's going to blow stuff up. So I'm quite curious at how this works. I was trying to think in my head, how would you do it, where you could actually just have a signal that you try one way, very low current, and then you try it the other way, low voltage, low current, and then you could see if you got continuity. So that way you could get it to work, you know, around diodes and stuff. So just throwing some of the parts on in however they might need to be, just to get a feel for the size of this thing. But yeah, it's going to be quite a neat little gadget. And I do like the inclusion of these pogo pins. That's quite cute, isn't it? It does say here though, probe 1 and probe 2, so that's the main one. So the pogo pins are going to be off that. And then I guess the idea that you're going to have this little blue wire coming off the other probe point, and then you're going to be touching stuff up. Oh no! Dang it, I will have to get the instructions now. I just realised, because it doesn't have the values. It has what the resistors are, but not the values. Curse you, Mitch Electronics! I guess that's what Google Lens is supposed to be for. Yeah. Continuity probe.pdf. Oh yeah, so it does have the little blue wire coming off. How it works, schematic explanation. Ooh, so it's 2 sub-circuits, a comparator circuit and a gated oscillator. It's so gated. That's quite nice though, isn't it? It's got the pictures of the resistors as well as their values, so you could just spot them. I'm not going to complain now. I should have printed this out. Maybe I still will. First things first, I'm using this handy tool that Brian Jones Power Crazy sent me a long back. I haven't heard from him for a while. Hope he's alright. But I'm using it to bend all of the legs, which is something I often didn't do, and it would be quite stressful. But 3D print one of these things, they're well worth it. Save you a lot of time. And then I'm going to poke them in the holes. So it's basically just a case of looking up the value by reading the colour bars off here, or off your multimeter if you're going to do it that way, and reading the values here. I'm sure you've seen it before, but look for R1 or R3 or whatever in the book, and then pop in the right value in the hole. And after a bit of struggle, it should look something like this. However, don't do what I do and actually did a little slip and then bent all the legs up like that. So that's a bit of a nightmare. But if that happens to you, don't worry. We do have a solution I'm going to be showing you now. And I'm going to use this technical item here that I just happened to find on my desk. Just a little cardboard box. Just need it to hold this while we solder it in place. Look, that works out all right, doesn't it? It worked out nice again, hasn't it? Oh yes, Gromit. We're mixing up TV shows. Aye. So I'm just going to poke these down, make sure they're sitting kind of as right as they are. So because these are through-hole plated, you can solder them from the top. So what I'm going to do is I'm going to actually just tack them all from the top, and I'm going to flip it over and do the other side. But this way I can focus on getting it about right. Now, not all components you can do this because of access reasons. So there's a switch that's going to go on here, right there, and that's going to be pretty much impossible to do because the switch body itself is going to cover everything. There we go. Getting all the tricky stuff out of the way. So the chances are, though, if you've got a modern multimeter, that you've already got this functionality. But there isn't something quite. There's not a feeling that you get when you use your own hand-built tool to fix something. So perhaps you'll get that joy out of using this little continuity tester if you build it. It wasn't a very expensive kit, it was a few pounds, so it's definitely affordable. There. And who knows, it might have some advantages over the ones you get in your multimeter. Maybe if it's a particularly cheap multimeter or something, it's just really laggy. Sometimes they're like that, actually. They're you can have really laggy continuity readings, and that is incredibly unhelpful. So just going to chop off the legs. And there's a good opportunity when you do this to inspect what you've done. Sometimes you find you've missed a spot. There you have it like that. And then what I like to do is just have another quick look over and just take that opportunity to actually put a bit of solder on the bottom. Belt and braces. Some of them have come through alright, totally onto the bottom layer. You'll see there, look, there's the little dimples from each of the solder blobs, but I like it to look pretty. Yeah, no complaints from me on that. That looks pretty good. So we've got some regular old plumbus. Pop in here some capacitors. There's no polarity on these, they're just little ceramic discs. So you just pop those right in. And there's one more here. And there is an electrolytic, but we'll put that right at the end because it's going to sit very proud. I'm going to use the opportunity to put in the IC blocks. Now have a look on the PCB, make sure you put these round. There's a little cutout, make sure that matches the cutout in the drawing on the board on the silk screen. You don't want to put them in backwards, because the chances are you might do some damage that way. So I'm going to attempt to flip this over. I'm not quite sure how I'm going to do this without everything falling out, so I'm going to put it on a brush. I'm going to try this, it might work. Yay! That kind of worked. The old brush technique that I just made up. What I'm going to do, again another trick, is just to tack solder. I almost said tack weld. Not quite welding here. One leg each, and then I can flip it over and then see if there's anything's moved like that. So then I can just put some pressure on it, heat up the one leg that I've done, get it into position, and then that's it. That's good, ready to go. Just going to make sure all the other ones are nice and flush to the PCB. Sometimes they look flush, but when you put the tiny bit of pressure on them as you solder, you'll feel it just snap into place. So that's those. So we'll start with the capacitors because frankly they're the easiest. Get them out of the way. And then that also allows us to cut their legs so they won't interfere with our main soldering. So I was discussing recently about manufacturing things when you get these made in factory, and it's not really so different. You might either have automation where you got a robot doing it, or you've got Far East automation where you've got someone else literally hand soldering it for you. Sometimes you don't really know what you're going to get because you're just paying a piece price. So it might just say assembly $1, $5, $10, a PCB. You go, yep, okay, that sounds good enough. And they'll work out how best to do it, whether they're going to use a robot or a person or a team. Sometimes it goes down to, you know, really quantity, and it might even be up to a few hundred. It will still be made by a person. Again, depending on what the yield rate would be from a human doing that job. So if it's soldering on some supercritical BGA or something, they might get a robot to do that, or they might just get a robot to do that one piece and not do the entire PCB, but just that, you know, the tricky parts. Might put those on first. Even when I make my own boards, I often do that. I'll spend a lot of time putting on the trickier main components. Don't like the way that electrolytic stands up. It'd be nice to have that bent over so it'd be more flush, but let's just leave it like that for now. Yeah, so what I do is I put on all of the surface mount ICs first. That way it gives me the most room to just sit there and flux them and get them nice, and then put the passives on later. Okay, so where are we? We're really just down to the switch and the buzzer now. Curious as to what sort of buzz this makes, if it's a pleasant buzz or an annoying one. There's our switch. So the switch is going to want to fall out right away, so I'm just going to bend one of its legs over a little bit just to kind of keep it there. I'm still going to have to push it up by hand, and same for the buzzer. Actually, the buzzer wants to fall out too, but there we go. Let's do the switch. So sitting up nicely, let's just do the buzzer. It's sitting where it's going to want to be. Pogo pin will be interesting. That's a kind of a non-standard mount, so we've not had to play with one of those before. I've normally put pogo pins as you'd expect, through a hole, through a normal through hole. And we'll just trim that off. Yeah, it's looking pretty good. We'll put the ICs on momentarily, but let's just get the old pogo pin on. So that's acting as the probe, one half of the probe. So I would go to so far to say that would be about right. I'd want it about that long. So what I'm going to do is tin this. So inside a pogo pin there's a nice big spring, so you really don't want to overcook that in case you damage the spring, so just be careful with it. No, I want you more centralized. Oh, it's getting hot. You want to make sure it's just straight. It's just not so straight right now. Come on now. Come on. Ah, no, too much. Because that's straight enough. Because you don't want to bend it, basically. Yeah, so if you bend it, you're going to damage the internals and the spring and all of that stuff. So that's where I kind of want it positioned. But there's no solder on the top, so I'd really like to get some solder on the top so it's definitely not going anywhere. And that will give me confidence that it is actually soldered in properly. So I'm just putting a blob on the iron and I'm just holding it on the top there. There. so you can see that it's a bridge over the top. It's like that pin's not going anywhere, and look, it's still pogos as you'd want. And then we have to attach probe 2. So probe 1 is built in and probe 2 is external. So it would be possible, you can see there's 2 pads here, to have this in a little box and just have your probes totally remote, which might be a nice way of doing it as well. So I'm just going to tin the pad for probe 2. I'm just going to tin the wire. Now, I rarely put things like wires through the through hole. That's entirely up to you, honestly. I don't know why we do, to be honest. It might be neater, perhaps, to do that, if you can. But I just normally will attach something like that. I'm going to kind of, I don't know, do you want it at an angle? I'm going to bring it out 45 degrees. Like that. Just because I kind of think you might not want it 90 degrees and you might not want it straight out. So bing, bing, bing. That's good. We're almost there. We're going to put the ICs in and then we're going to hook up the battery clip. So this is the what was it called here? It says 8AAL4J 4093 though. I think the CD 4093 is the number off that one. Bending it, making sure all the legs are nice and even Steven with each other. It's kind of cute. It's got an on-off switch too, so it does show you that it is an active circuit. It's not just relying on the actual continuity to make up the circuit that gives it power. It's got the battery snap, positive and negative. Let's go with red being positive and black being negative. Usually is these things. Again, I'm doing my just surface soldering it. Surface mount. Oh, very exciting, and I do have a battery to hand. So just clean away all the chaff. Now what was strange is it did have an extra resistor in the kit, and I did check in the instructions and it did say there was going to be 4 of them, so I don't know why they included that. So let's turn it on. Ooh, nothing. Okay, well that's good. Let's get a piece of PCB, so some random PCBs from something. And I don't know what has continuity on this and what doesn't, but I'm going to hold this up to the ground to start with. Well, that's pretty instantaneous. I can see a diode here. It looks like a diode. Did you hear that briefly? Let's see what happened on there. So we're going to go this way. Nothing, no dioding action. I'm going to flip the board and then do the diode the other way around. I heard it squeak. So that's a bit weird, isn't it? I was really hoping it would have been able to go through them. I mean, you hear it doing something, don't you? And then just gives up. That's through a capacitor, through a resistor. Yeah, so it's kind of just. So I'll give you an example though of what a regular meter looks like. So this is a regular continuity meter. Let's see if what this does. I think you kind of cheat in a way because you do get the resistivity on the screen too. So that's through that diode. We've got overload and overload, same thing. So I guess it's fine. It's not being any different. The main difference is, you see here I've got a resistor. I can always see on the screen that there's something through there, and to me that's like, yeah, that counts as continuity, even though I'm not getting the beep. That's something I'll be lacking in that. But you know, can't complain. What if we put a voltmeter though on this? Should we see what we can see if we put a voltmeter on the end? How many volts? Half a volt. Well, 0.6. 0.6 of a volt. So it'd be almost enough to trigger the base of a transistor a little bit. But that's okay. There you go. That works. I would probably change this probe though. I'd probably put something a bit more probey on that. I'm going to have a quick look though in my box of stuff to see if there's any way we can kind of protect all of this. I suppose something like this bit of heat shrink would work. Probably make a hole for our wire to come out of. Let's do that first, shall we? I'm going to guesstimate it to be around about here. Poke that through. Boom. And you're back in the room. Now let's see if there's any chance of us shrinking that down. Remember, we've got a switch in there to deal with, but we'll have to get that after. Yeah, not so compact. Not with a 9-volt battery. Suppose you could put a lithium cell. It's a shame actually. I'd have rather a few button cell type things, or the lithium CR. Is it 2306 or something? You know the ones I'm talking about. They're quite prolific now. Everything seems to be using those little lithium discs. But I don't know, it's probably not too bad. So we've got our little switch here. Yeah, probably would have been a good opportunity to extend that though, to make it a little bit more useful. But yeah, let's pretend we're probing. So I normally would hook something onto a ground like here, and then I'd want to see what else has given me ground. Just not long enough. Yeah. Anyway, there you go. That is the Mitch Electronics kit. What they call it really. It says serial number 90. So I don't know if it's their kit 90. But yeah, mitchelectronics.co.uk. And tell them I sent you. Maybe they'll send me a free kit or something to do a video on. And you could probably do a better job than I did in wrapping it up. As ever, thanks for watching.